Okay, so this lesson is about row reduction and echelon forms. So basically, we're going to continue solving linear systems using elementary row operation like what we did in the previous section, but we will precisely lay out the procedure of how to do that. So the row echelon form is a form of matrix that has non-zero rows above the row of all zeros. So this means that we just push 0 rows to bottom, and all the leading entry of a row is to the right of the leading entry of the row above it. And this means we push the longer row to the top. Entries below a leading entries are 0. So basically what it means is that, so if you look at this example, we have this thing as a leading entries. You can see that the longest row comes to the very first row and the smallest one comes to the bottom. So basically it really looks like upper triangular shape. So if you look at the other example, you put the 0 row to the very bottom of the matrix. And these things are non-zero numbers, which can be a leading term of each rows. And all the stars over here is just any numbers. A matrix is reduced row echelon form if, in addition, we have leading entry equals to 1, and 1 is the only non-zero entry of the column. So basically, if you look at the example below, we have 1s as the leading terms, and each leading one is the only non-zero entry for each columns. And similarly, we have leading ones over here, and this is the only non-zero term of each columns. Does it make sense? So we call both REF and RREF as the echelon forms, and people, including myself, frequently call RREF as a verb, like RREF this matrix, something like that. And this means that use elementary row operation to reduce the given matrix into the reduced row echelon form. And we can reduce each matrix into the unique RREF matrix. However, REF is not unique, because you can multiply any numbers to each rows. Pivot position is the entry corresponds to the leading one in RREF, and pivot column means it's the column containing a pivot position. In fact, we can find out pivot positions and columns from either REF or RREF. So basically, leading entries in REF is basically the same as the leading entries in RREF. Okay, so let's look at the given examples and identify where's the pivot position and pivot columns. So this is the REF of a certain matrix. Here, the pivot position corresponds to the location of the leading terms, and the pivot columns are the columns that the leading terms are located at. So here I want to note that numbers like 1 and 2 and -5 are not pivot positions, but pivot position is the position. So that is to say, for this one, this is located at the first row and first column. So we say it is 1, 1 entry or 1, 1 position. And for this one, it is located at the second row and second column. So it's 2, 2 position. And for -5, it is at third row and fourth column. So we say it is at 3, 4 position. And note that we always write in an order of like row, comma, columns. So we have two different matrices. For part A, we have 3, 5 matrix. And for part B, we have 2, 4 matrix. So let's pause the video and try out for both part A and part B of this exercise. Okay, so let's solve these problems together. So the first thing we want to do is to add first and the third row. So we have 1, -7, 0, 6, and 5, 0, 0, 1, -2, and -3. And if you add the first one to the third row, then this gives you 0, 0, -4, 8, and 12. Okay, and then we multiply by 2 on the second row, and then add it to the third row to reduce the third column. Then this gives you 1, -7, 0, 6, and 5, 0, 0, 1, -2, and -3, and 0, 0. Oops, we had to multiply by 4. Then this gives you 0, and I guess this entry is again 0, and that one is again 0. And I guess this is REF, and this is also the RREF of the given matrix. So here we have pivot position at here and here. So the pivot position is 1, 1 entry, and the other one is on the second row and third column. And pivot column is first and third column. Similarly, we first want to eliminate this guy first. So we want to multiply 2 on the first row, then and subtract this from the second row. So if you multiply by 2, that gives you 2, 2, -5, or -10, 6. And the second row was 2, 4, 0, 9. So if you subtract this 2, this gives you 0, 2, and 10, and 3. So the given matrix is row equivalent to 1, 1, -5, 3, and 0, 2, 10, 3. Okay, I think this is a REF of the given matrix. And now we have to reduce the second column to get the RREF. So basically, we want to multiply by, or we want to divide by 2 for the second row. And that gives you 1, 5, and 3/2. And this is row equivalent to, so now we want to kill this guy to attain the reduced row echelon form. So we subtract the second row from the first row, and this gives you 1, 0, -10, and I guess it's 3/2, and 0, 1, 5, and 3/2. So this is the RREF of the given matrix. So here we have pivot position as 1, 1 and 2, 2 entry, and these two things, and the pivot column corresponds to the first and the second column. So basically, RREF in an augmented matrix is the equivalent to solving the system of linear equations. Okay, so basically, if you write the system of equations in terms of the matrix, we get 1, -7, 0, 6, and 5, and 0, 0, 1, -2, and -3, and -1, 7, -4, 2, and 7. And this matrix is the same as the matrix given above over here. So we know that the matrix is row equivalent to 1, -7, 0, 6, and 5, 0, 0, 1, -2, and -3, 0, 0, 0, 0, and 0. So from here, we get a new system of equation. So this is equivalent to x1 minus 7x2 plus 6x4 equals to 5, and x3 minus 2x4 equals to -3. So here we have 4 indeterminate, or 4 variables, and 2 equations, which means we can think of 2 free variables, right? So if you move 2x4 to the right hand side, then this gives you x3 equals to 2x4 minus 3. And also if you move these two terms to the right hand side, then we get x1 equals to 7x2 minus 6x4 plus 5. So basically we can conclude that x1 is this, and x3 is this, and x2 and x4s are free variables, which means you can put whatever numbers you want. So basically in this example, we know that these two entries are pivot positions. So pivot columns are here and there. And the first column corresponds to x1, and the third column corresponds to x3. And these two variables are called as basic variables. And this means we can solve them in terms of other variables. And these other variables are called as the free variables. So in this case, x2 and x4s are free variables. So let's pause the video and try out the second part of this exercise. Okay, so again, the augmented matrix corresponds to this system of equation is basically this one, which is again the same as the matrix given above here. So we know that this is row equivalent to 1, 0, -10, 3 half, and 0, 1, 5, 3 half. So here we have pivot columns along the first and the second column. So here we can imagine that x1 and x2 are basic variables, and x3 is the free variable. So the augmented matrix gives us an equivalent system of equations. So basically, I guess it's x1 minus 10 times x3 equals to 3 half, and x2 plus 5x3 equals to 3 half. And we can solve for x1 and x2, which gives you x1 equals to 3 half plus 10 times x3, and x2 equals to -5x3 plus 3 half, and x3 is a free variable.